Hi everyone, it's Sorkin. Today we have a problem when we are given an array where each element represents the number of jumps that we can make. For example, from here, from the first index, 0 index, we can go to first and second, so the value equals to 2. From the first index, we can go to here, the first element, second element, and third element. And we need to find the minimum number of jumps. So in our case, it equals to 2 because we can jump from the 0 index. We can make 2 jumps, right? But we are making 1 jump. So we are going here. And from here, we go from the first index. We can make 3 steps. So our jump is equals to 3. So that's why we are returning 2. So how we are going to solve this problem? The way we are going to solve it, we are going to use a dynamic programming approach. In our case, let's take actually our array and let's work on it. So we have 2, 3, 1, 1, and 4. So we are using dynamic programming bottom-up approach. So for that, we are going to create the array of the same, we are going to create array of integer of the same size of our array. And for each step, what's the idea behind the dynamic programming bottom-up approach? The idea is that we are solving a sub-problems that help us to build up our solution, where we are getting the solution for our problem. So basically we are breaking down our problem to sub-problems. First we are solving the sub-problems, and then we are building up to our solution. So for example, in this case, we are creating an array. Let's call it dynamic programming, right? And so in this array, we are setting all the values that to integer maximum, right? The maximum of the integer. Let's just for now mark them as maximum, and we are going to update for each of these. So for each, how many jumps it takes to go to this point, and to this point, we are going to update all these values. So let's first start with the first one. The first one is that, so how many steps it takes to come to this point, right? So it takes 0, so we are not making any jumps, so we can right away update this value to 0, right? So this value is 0, so it takes 0 steps to go to the 0 index. So how about this first one? The first one is we can make a jump from here. So for that, we are going to maintain 2 values. So the first value is that our current, which is equals to from our array, right? So we are taking dynamic programming I plus j, that's the current one, and the new value is going to be dpi plus 1, right? Plus 1. And we are going to take the minimum value of this, right? Whatever the minimum value is, and we are going to update in our array. So let's go to our array. So the first one is that so now first our I and the j. So our I here, right? And our j is here, right? We are just starting out. They both start equals to 0. So first let's do that for the 0 index, right? dpi plus j is equals to 0 plus 0. So let's do it for this element, right? So dpi is equals to 0. J, we are moving now here, right? Because we can make 2 steps. J represents our max steps, right? Our max steps. Okay, so we are moving our j here. Now j is equals to 1, right? So dpi plus j is equals to what? To 1, right? This value now, this value is equals to 1, right? Is equals to 1. How about the dpi plus 1? dpi plus 1, our I is equals to 0, plus 1 is our current value. So dpi plus j, so it's not 1, but it's max, right? This value is max. So, and how about the value of dpi? dpi plus 1. dpi is equals to 0, plus 1 is 1, right? And we are taking minimum of this. So minimum of this between max and 1. So we are updating this value. To 1, right? So now we are moving our j because we can go 2 steps, right? So we are moving our j here. Now our j is equals to 2. Now our j is equals to 2. I plus 1, I plus 2, so gives us 2, right? dp2 is equals to what? dp2 is equals to maximum, the same, right? And the dpi, in dpi, it's 0, right? So because we are coming from here, and the dpi is still equals to 0, 0 plus 1 is to 1, so we are updating this value again to, we are updating this value to 1, right? So we are updating this value to 1. Now we are moving our I. Now we explored all possible options for this one, right? So because we can move our I only 2 steps. So we have explored all the options for this one. Now we are moving to the next element. So from 3, right? How many steps we can go? We can go 3 steps. We can go to here, here, and here. And let's go and update our value for each of them. What's the value of dpi plus j? I is equals to 1, right? I is equals to 1, and the j is also equals to 1. So dpi plus j, the value is 1. So here, for this case, right? For the 3, the value is now equals to 1, because this one is equals to 1, right? Here, this one is equals to 1. Or we are choosing a new value, which is the value of dpi. In our case, I is equals to 1. So this value plus 1, so it's now equals to 2. So what's the minimum between 1 and 2? It's 1, so we are keeping 1, so we are not touching it. Now let's move our j here, right? Because we can move 3 steps. We are moving our j here. Now our j is equals to 2, so 1 plus 2, so what's the value? So what's this value? This value is maximum, right? This value is maximum, so our current value. And what is the new value? The new value is whatever the value of the d here, right? Because we are making jump from here. So this value plus 1, because we are making, this is one jump, right? So plus 1, so 1 plus 1 is equals to 1 plus 1 is equals to 2, it's 2. So between maximum and 2, we are updating this value. We are updating this value to 2. The same way, so since we can go from the first index, we can go, so we can move our j here. We are moving our j here again. And the value, what's the value here? The current value is maximum. And what is the new value? New value is we are coming from here, right? From the first index, and the value is here 1. 1 plus 1 is equals to 2. So that's why we are updating this value to 2, right? So now we have explored all the options also for 3, right? Now we are moving to this next index, and we are exploring. Now our I is equals to, now our I is equals to is equals to 2, right? We are moving to the second index, and the same way we are exploring the option for this index, and this index. At the end, once we reach till our last index in our array, in our DP, we will have the minimum value, minimum jumps that we need in order to reach the end of the array. Okay, first thing that we are gonna do, let's create our array. Dynamic programming, right? It's gonna be the size of new int. It's gonna be the size of our num's length. Okay, so, and after that, we are gonna fill our array with the maximum value of integer that we are going to replace later, right? So we are gonna fill that with our DP with the integer max value. Integer max value. Okay, so after that we can go and before going to and building up our solution, so we are going to set, so for dp of I, right? So it requires 0 steps, go to the first index, right? So it requires 0 jumps. So we are going to set that to 0. Now we start to explore our solution and build up our solution. So for that, let's do that. So we are going to do int I is equals to 0. I is less than our num's length, right? Num's length, and I plus plus. And also now we need to check what is the maximum jumps, right? So let's take the maximum jumps that we can make. So we are gonna move our J pointer until our max jumps, our J pointer, whatever the value of the max jump is. So, and we are taking that value from nums I, right? Whatever the value is there. And now we are exploring the options and updating our DP array. So we are starting from the first one, from the first index for our J equals to 1, right? And we are, until our J is less than or equal to our max jumps, and our, so we should not exceed the size of our array, right? So for that, I plus J should be less than our nums length, right? And we are putting here J plus plus. So for that, now we are taking our current value. What's our current value? Our current value is that our value, so the current value of that index, right? So dp, we are taking I plus J, right? Whatever the current value is. And our new value, since we are making one step, let's call it new value. So our new value is equals to dp I. So the cell where we started from, right? The index where we started from, and since we are making one jump, we are adding 1 here, right? We are adding 1, and we are updating our dpi plus J. So we are dpi plus J, we are updating with whatever the minimum value is. So math minimum, we are taking the current value and the new value. Okay, and that's it. At the end, once we exit this loop, so we have solved all the sub problems and we build up to our solution. So we are just returning our dp n minus 1, right? In our case, n is nums length, right? Nums length minus 1. Let's run it. Okay, great. It works as expected. And now let's calculate our time and space complexity. What's our time complexity? Time complexity in our case, we have 2 loops, and in worst case, this in here, right? So if everyone has the max jump is equals to n, so in that case, our time complexity is going to be n squared. So it's going to be n squared because of this inner loop in worst case, right? How about the space complexity? Space complexity is determined by the size of our DP array, which is in our case is n. So we are going to set that to n here. Okay, that's it. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.